Hello everyone, my name is Sakshi KV and my USN is 2ST22EC073. I am from STM 6th SEM B Division and my CTA activity is to write a C program to simulate selective repeat protocol. So let's begin by understanding what ARQ means. ARQ stands for Automatic Repeat Request. It is an error control method used in data communication. When data is sent over a network, it might get corrupted or lost due to noise or other issues. ARQ protocols help ensure that the data is received correctly by requesting retransmission of any lost or erroneous frames. There are several types of ARQ protocols such as stop and wait, go back N, and selective repeat. Today we are focusing on selective repeat, which is more efficient than the others. So what is selective repeat ARQ? Selective repeat is a sliding window protocol used at the data link layer. It allows the sender to send multiple frames at once without waiting for an acknowledgement for each one. However, if a frame is lost or contains errors, only that specific frame is retransmitted rather than all the frames after it. This makes it more efficient, especially when working with unreliable or slow conditions. One more key feature is that the receiver in selective repeat can accept frames out of order and store them temporarily until missing frames arrive. So it has a buffer and doesn't reject all frames just because one was missing. Let us consider an example. Suppose the sender sends frames 0, 1, 2, and 3. If the frame 1 is lost, the receiver will still accept frames 2 and 3 and send acknowledgements for them. The sender will only resend frame 1. In contrast, in Go Back N, the sender would have to resend the frames 1, 2, and 3. This saves a lot of time and bandwidth. Let me explain how we simulate this using a simple C program. I have used an online compiler to compile this program. In our simulation, we assume that we are sending 10 frames. We also define a window size, let's say 4, meaning the sender can send 4 frames at a time before stopping to check which ones were acknowledged. We create an array to keep track of which frames are acknowledged and which needs to be resent. In each round, we send the frames in the current window. We then simulate whether each frame was acknowledged or not. If an acknowledgement is received, we mark that frame as completed. If not, we leave it to be resent in the next cycle. After that, we slide the window forward only if the earliest frames have been acknowledged. This mimics the real behavior of selective repeat ARQ. Here's the part of the code that works. We define, that is the frames, the total frames. We use an array. Next, we loop through all the frames. Inside the loop, we have two steps. Send frames within the window. Ask the user to enter 1 or 0 to simulate whether a acknowledgement was received. If the user enters 1, we assume the frame is acknowledged and mark it. If 0, we don't mark it and the frame will be resent. After checking acknowledgements, we move the window forward using while loop. This ensures we skip over the frames that are already acknowledged. The process continues until all frames are sent and acknowledged. This simulation is a simplified version of what happens in real networking systems. In actual protocols, the sender and receiver would handle these operations using timers, sequence numbers, and real transmission mediums like TCP/IP sockets. But this simulation is very useful for understanding the logic and behavior of the selective repeat ARQ. The advantages of selective repeat ARQ. It saves bandwidth by not resending unnecessary frames. Second, before getting into advantages, This is the output that we have got from the simulation. So we are sending the frames, that is 0, 1, 2 and 3. The acknowledgement is received for 0 and then 1. Then there is no acknowledgement for 2 and 3. Then we are again sending the 2 and 3 frames with 4 and 5. Then acknowledgement is received for 2 and not 3, and acknowledgement is also received for 4 and not for 5. So we will send those frames which have not received the acknowledgement, that is 3, 5 and 6. After all the frames have received acknowledgements, then we send 7, 8 and 9. Once acknowledgement is received, then all the frames are sent successfully is printed. The advantages of selective repeat ARQ. First, it saves bandwidth by not resending unnecessary frames. Second, it allows for better efficiency in long distance or high delay networks. Third, it handles errors and retransmissions in a very smart and selective way, improving performance. It is used in real life systems like wireless communication, satellite links, and in protocols like TCP and selective acknowledgements are enabled. To conclude, selective repeat ARQ is a very efficient and smart error control method. Our C program shows how we can simulate this protocol by sending multiple frames, accepting acknowledgements, and selectively resending the ones that failed. Thank you.